Hi, welcome to the workshop here at Electricity Northwest. We're going to spend a little bit of time looking at electricity and circuits. This is a circuit board. It's a circuit board that I will be using today to explain to you how a circuit works. A circuit is just a loop of electricity. It starts here and it ends here. These things, we call them batteries, but the proper electrical term is they're actually called cells. So they provide the power for the circuit. This is a switch. It works exactly the same as the light switch that you have at home. You can't see how it works, you just press a button and click, it comes on. This is what is behind the plastic, works in the same way. Here we have three bulbs, or as electricians call them, they are actually called lamps. We have three of these to connect up, and we also have a variable resistor here. Connecting them all together using crocodile clips, we connect them to these, which are called terminals. Where do you normally find terminals? We have bus terminals, we have rail terminals, we have plane terminals. They are where we connect lots of different things together. Here, it's how we connect all the different elements of the circuit together. And that is our circuit board. First up, we have the simple circuit, which, as you can imagine, is quite simple, straightforward. We have a circuit board here, we have two cells, and we're going to connect those two cells up to a bulb. I'm going to start off with these are crocodile clips. I'm going to connect this crocodile clip to the positive terminal of the battery. Connect it up here. This next end, I will connect to the first terminal of the switch. This one to the top terminal of the switch. I will then connect it to the left-hand terminal of the bulb. That's us halfway there. Black connecting wire, look at this. Crocodile clip connected to the right terminal of the bulb, and then back down to the negative terminal of the battery. And here we have a complete circuit. Is the light on? No, because I haven't pressed the switch yet. As soon as I press the switch, that's when the magic happens. 3, 2, 1. Yay! And there we have it. The light is on because I have closed the gap here in the switch, creating a flow of electricity from the positive terminal all the way back round to the negative terminal of the battery. An unbroken circuit. Simple circuit. In a simple circuit, we have a power supply, we have batteries, a switch, and a bulb. Keep it simple. Next up, we have the series circuit. Now, the series circuit is my least favourite circuit. Everyone should have a favourite circuit. This one is my least favourite circuit, and we'll see why. So I'm going to start off connecting a crocodile clip up to the positive terminal of battery cell A here, and I will then connect it to the bottom terminal of the switch. I will then take the next connecting wire, connect it to the top terminal of the switch, connecting this to the left terminal of the top bulb. Black connecting wire, right terminal. So we have the same as the simple circuit. We've got to the top bulb and it's the same. This is where it changes. We're going to snake it down through all of the bulbs now. So I'll take it down to the right terminal of the middle bulb. Left terminal of the middle bulb, down to the left terminal of the bottom bulb, then the right terminal of the bottom bulb to the negative terminal of the battery cell. And there we have a series circuit. So the electricity flows from this cell up the connector wire till it gets to the switch, through the switch, up to the connector wire, through to the top bulb, through the bulb, down out the other side, along this connector wire, through this bulb, through this connector wire, back to the bottom bulb, all the way down until the journey ends at the negative terminal of the battery cell. And this is a series circuit. So when I flick the switch, you'll see why it's my least favourite. And if you can really strain your eyes, the 3 bulbs are on, but they're all quite dim. Hard to see. Now, if I take out one of the bulbs, see what happens. All of the bulbs go out. I put that back in. They're back on, but whenever I take a bulb out, it stops the electricity flowing around, lighting the other bulbs. It creates a break in the circuit. So whichever bulb I take out stops the electricity flowing all the way back to the battery. So it makes the circuit incomplete. And that is the series circuit. Christmas tree lights are a fantastic example of a series circuit. If one bulb stops working, they all stop working. Yay! Okay, we have the parallel circuit next. The parallel circuit is a bit different from the series circuit. The series circuit is a series of bulbs, like a TV series, one after the other. Parallel is wired up slightly differently. Same thing, 3 bulbs, 2 cells, but let's see how different it is. So if I connect up the positive terminal of the battery, bottom terminal of the switch, top terminal of the switch, over to the left terminal of the top bulb, right terminal of the top bulb, and we take this all the way back down to the negative terminal of the battery cell. And there we have, can you remember what this is? This is a simple circuit. It's the first one we made, but we're going to make this one slightly different because this one's parallel. So I'm going to now connect up another crocodile clip to the top of the switch. I'm going to take this down to the left terminal of the middle bulb, connect up the right terminal of the middle bulb, and I'm going to connect that up to the negative terminal of the battery. I'll take another connecting wire, connect it to the top of the switch, take that down to the left terminal of the bottom battery, and we only have one terminal left to connect up, which is the right terminal of the bottom bulb. And to end it all, that needs to finally go to the negative terminal of the battery cell. And so this is a parallel circuit. 3 bulbs lit in parallel. Now let's see the difference when I press the switch when we compare that to the series circuit. Can we see that they're a bit brighter? The last one looks a little bit dim, but these are a lot brighter. Now, the difference is when I take out this bulb, ta-da! Magic. The other ones stay on. Do you know why that is? That's because each bulb has its own little mini circuit. Like the simple circuit, it's like 3 simple circuits all joined up together. 3 circuits a circuit within a circuit within a circuit. Put that back in, and it doesn't matter which bulb I take out, the other ones will stay on. There we have it. Third one back in, and that is the parallel circuit. The lights in our house are all wired in parallel. This means if one goes out, the rest stay on. Next up, we're going to look at this thing here. This is the variable resistor. You're probably wondering what the variable resistor does. It varies the resistance. Okay. So, first up, let's, as always, connect up the battery cell to the switch. We're going to take that from the top of the switch to the left terminal of the bulb. Then we're going to take it from the right terminal of the bulb. We're going to connect it up to the variable resistor. Okay. Then I'm going to connect up the negative terminal of the battery, and then using this spare end here, close the switch and then connect up the crocodile clip so that it's touching the wire on the variable resistor. Now watch what happens as I move this crocodile clip further up. Can you see what happens? It goes dim and then turns off. If I then slowly bring it back down, you can see it just coming on until it gets to the bottom where it gets really bright there. So bright and then dim. So that's how a dimmer switch works in your house. And it's due to the length of wire here. When it's connected here, it only has a short distance to travel down this wire. So it only has to travel that far before it reaches the end of the circuit. The further away, the more resistance there is in the circuit, which dims the bulb. That's the variable resistor. A variable resistor allows us to increase or decrease the amount of resistance there is in a circuit. In a dimmer switch, more resistance makes the bulb dim and less resistance makes the bulb bright. In a stereo, more resistance keeps the volume down, less resistance lets us blast out some tunes. Okay, next up is the mortar. So let's get some mortar action going here. I'm going to connect up the battery cell to the switch as always, starting the flow of electricity running up to the switch, from the switch, powering up the motor, going to the positive terminal, then taking it from the negative terminal of the motor down to the negative terminal of the battery. And when I press the switch, we should see the motor spinning round. Now, I don't know if you can see this because it's quite fast, but to me that is spinning anti-clockwise to you, clockwise to me. Now, if I change these wires and I connect up the negative terminal first and then the positive terminal, what do you think will happen? Let's find out. Can you see that it's now changed direction? This is because we have changed the polarity in the circuit. We have changed the way the electricity flows through the motor. And that is the motor. When we have a simple circuit with a motor in it instead of a bulb, we can do something a little bit different. We can swap around the flow of electricity to the motor. When we do this, it changes the direction in which the motor spins. Right, next up, the buzzer. Let's get buzzing with the buzzer. So, connecting up the positive terminal of the battery cell, as always. I'm going to connect that to the switch, take it straight from the switch to the positive terminal of the buzzer. Then we're going to take this next crocodile clip, negative terminal of the buzzer, down to the negative terminal of the battery. And then we've made a complete circuit again. It's just like the simple circuit that I did before with the bulb, but instead of the bulb, this time it's a buzzer. It's the same with the motor. It's just a simple circuit, but we've replaced the bulb with another appliance. So let's see if the buzzer works. Buzzing. Another example of a simple circuit is the doorbell. This time, when you press the button, instead of a light coming on, you get a mildly annoying noise. Don't forget to visit our online hub for all your electricity themed resources for pupils aged 7 to 16. Get yourself there. Buzzing.